these are our standard techniques that we've got to offer. We can look for an arithmetic sequence when a sequence comes up. We can look for a geometric one. Or we can look for something a bit creative. And there are our three standard techniques. Sometimes we've just got to be a bit creative, right? Because it might not follow a normal arithmetic sequence, nor follow a normal geometric sequence. But there's something about the numbers as soon as you look at them, right? The 1, the 2, the 3, the 4, and the 5, and down here, the 2, the 3, the 4, the 5, and the 6. Even though that they're fractions, rationals, right, the fact of the matter is the numerator appears to be an arithmetic sequence. There's an arithmetic sequence there. And the denominators themselves are an arithmetic sequence as well. There's an arithmetic sequence here, and there's an arithmetic sequence up here. So why not treat the two arithmetic sequences in turn, and then come up with a general nth term? If we try some other approach, if we look for a common difference between the whole numbers themselves, we won't find it. Right, but fortunately, there's an arithmetic sequence there for us in the numerator, and fortunately, there's an arithmetic sequence there in the denominator. Alright, now, this is what we're after. We're after that nth term. Okay, in both cases, the numerator and the denominator, what have we got? We've got an arithmetic sequence. So, let's just apply our general nth term formula to the numerators and to the denominators in turn. And then hopefully we'll get a general nth term, right, for whatever the next rational in the sequence would be after. Alright, let's see how we go. Well, perhaps for the sake of interest, let's put the formula up just once again. Here we are. Here's our nth term formula. A equals A1 plus n minus 1 times d. Alright, now can we apply it to the numerator? Okay, so our general nth term this time, for this sequence, an equals. Now, it's going to be a fraction, whatever it is, right? Because all the terms in turn in the sequence are fractions. Okay, so what have we got? If I look for an AP or an arithmetic sequence up here, the first term, the first numerator there is 1 plus n minus 1 times whatever the common difference is. Well, what's the common difference up here? It's plus 1 each time. Alright, so here, 1. Now, in the denominator, the first term is 2. And then we've got n minus 1 times the common difference. The common difference this time is 1. Plus 1, plus 1, plus 1, plus 1, etc. Alright, so this is 1. Alright, if I sort that out, let's see what we get. It'll be 1 plus n times 1 minus 1. So it looks like it's just going to be n. Right, the ones will cancel. Down here we've got 2 plus 1 times n is n, minus 1, so it's going to be n plus 1. And that's what. And there's our nth term. Now, how else could it have been done? Let's have a look at that for a moment. Half, 2/3, 3/4, 4/5, 5/6. Now, I could have done this just like I did in the introductory lessons. I could have said, there's the first term, there's the second one, there's the third one, there's the fourth one, there's the fifth one, like that. And then we could have gone 5, 5, 4, 4, 3, 3, 2, 2, 1, 1. And start it off and then go, alright, well the nth term must be, right, where it's 5, it's 5 there. Where it's 3, it's 3 there. So if it's the nth term, it must be in there. And then of course this number down here is 1 more than the one above it. This one is 1 more than the one above it. This one is 1 more than the one above it. So if that's n, that must be n plus 1. Either way, it's okay. Either way, it's fine. This one uses our idea of an arithmetic sequence in the numerator and denominator. This one uses just a little bit of creativity. Going back to the original number of terms, having looking at the term number and the numbers that appear in the fractions in the sequence themselves. either way is fine.